For this presentation, I'll be discussing the biomechanics of running and walking. Let me first explain a few of the principal differences between running and walking. First off, walking and running have different velocities. Also, the characteristic feature of running is the aerial phase, when both feet are off the ground. Now that I've covered some background information, I will move on to the efficiency of running versus walking. Efficiency is a measure of the ratio of metabolic power to mechanical power. To be more efficient, the goal is to get the greatest amount of mechanical power from your metabolic input. Efficiency is never 100%, however. Metabolic power always exceeds mechanical power. Walking is considered to be more efficient than running. During the first half of stance phase, velocity decreases, but the height of the hip increases. This means kinetic energy has been converted to potential energy. At mid-stance, the hip is at the highest point. Therefore, gravity propels you down to the bottom during the second half of stance phase. The potential energy is converted to kinetic energy. Since walking uses gravity to keep you moving, less energy is needed. As you can see from these graphs, the total energy is constant for walking because the kinetic and potential energy are out of phase. Throughout the entire stance phase, you are constantly recovering and returning energy to the system. As opposed to walking, during running, potential and kinetic energy are in phase with one another. In the first half of stance phase, there is a decrease in both velocity and potential and kinetic energy. The hip is at the lowest point during mid-stance in order to preload the muscle and joint. During the second half of stance phase, velocity and potential and kinetic energy increase. The elastic energy stored in the leg is used to propel you forward while running, much like a spring. Therefore, since kinetic and potential energy are in phase with each other, the total energy in running decreases in the first half and increases in the second half. So overall, walking uses less energy because it takes advantage of the inverted pendulum model, which is less costly than running due to the conservation of mechanical energy. Any change in kinetic energy will be offset by an opposing change in gravitational potential energy, with no need for mechanical work performed by the muscle. Another topic I will discuss that also relates to performance and technique in running versus walking is the ground reaction force. The ground reaction force is the equal and opposite force applied by the ground onto the body. There are two different graphs used when looking at ground reaction forces, a vertical one and a horizontal or anterior-posterior one. The horizontal graphs for running and walking are pretty much the same. There is a deceleration phase at the beginning of stance, followed by an acceleration phase in the second half of stance. The vertical ground reaction force graphs for walking and running are quite different, however. The vertical GRF graph for walking is M-shaped, while the vertical ground reaction force graph for running is N-shaped, with an impact peak that loads the bones and a larger active peak at mid-stance that loads the tissues. The impact peak is smaller in duration, but varies a lot from person to person depending on the way they land, their body weight, and orientation. People who land on their rear feet or heels during running tend to have a more profound impact peak because they are loading the bones at a greater magnitude. Mid-foot strikers tend to have a larger active peak with a very small or sometimes absent impact peak. This loads the tissues with increased pressure and force. These high pressure points can cause a breakdown in tissue or bone depending on where the pressure point is localized and how much excessive loading takes place. The final factor that I will discuss is footwear. The cushioning and support in shoes tries to minimize risk of injury. Running shoes are often heavily cushioned with an elevated heel, which results in rear foot striking. However, when runners are asked to run barefoot, they often shift to forefoot striking. This raises questions regarding method of striking and injury risk. In terms of injury, midfoot and forefoot strikers load the soft tissues more than the bones and thus are at greater risk for injuries that involve tendon, ligaments, and fascia, such as plantar fasciitis. Rear foot strikers load the bones with greater magnitude, so they are at a greater risk for bone injuries, such as stress fractures. When looking at different types of shoes, runners must take into account cushioning, control, and stability.